Hi guys, good evening. Hello guys, good evening. So today we will be learning about solution of system of linear equation. And in previous class we have learnt about the matrices. So this is one of the important topic which we are going to learn, that is the solution of system of linear equation. So hi Meghla, I'm good. What about you? So yes, so this is one of the important concept and you already know, right? So for in matrices, when you talk, all the things are deleted mostly. So in that, your solution of system of linear equation is that. So mostly from matrices, the questions they might ask is from this concept. So this concept they can ask for your in 4 marks. Definitely they can ask this concept. Okay, so can we start? Yeah, you do comment, right? Every often you do comment, so I definitely know. So yes, let's quickly start the session. Now, yeah. So the solution first, when you see, it is consistency of system of linear equations. So what do you mean by consistency? So generally, when do you say a system is consistent and when do you say the system is not consistent? So suppose if your system is consistent, so when do you say? So consistent, which means a system. If a system of linear equations has one or more solution, then you know it. Then you can call it as consistent. So has one or more solutions. Then what can you call the system? Then you can call the system as consistent. Okay. Then the system is said to be consistent. Okay. Otherwise, what can you call it? So if your main point is if the system has one or more solution, then you call the system as consistent. Otherwise, what can you call? The system is called as inconsistent solution. So, inconsistent. Okay. So otherwise, it is called inconsistent. So otherwise, how is it called? It is called inconsistent. Okay. So this is basically about the consistency. Now let's see, if you're having two or more solution, those solutions can be unique or the solution can be the solution can be same. Otherwise, the solution, there exists no solution, right? How can you say by looking at the matrix itself, how can you say whether the system is unique solution, has unique solution or different solution or no solution, right? So that we'll be seeing. So when I further do, so in fact, a unique solution is always called a consistent solution. So a unique solution, the system is called a consistent solution. How is the system called? The system is called a consistent and independent solution. So if your solution is unique, then what can you call? Your system can be called as consistent or and unique, which means and independent. Okay. So basically your unique solution means it is consistent and independent. Okay. Now if you have infinitely many solutions, what happens? If you're having infinitely many solution, then again your system is called a consistent consistent system and a dependent system. So infinite number of solution. So infinite number of solution, comma, the system is called, how do you call the system? It is called consistent and dependent. So how do you call it? It is called consistent and dependent. So basically your infinite number of solution, it is called consistent and dependent. So when you're having consistent solution, either it is a unique solution or infinitely many solution. Now if you have no solution, then what do you say? If you're having no solution, then that is called inconsistent solution. So no solution, the system is called inconsistent solution. Basically, if you're having no solution, then what can you say the system? It is inconsistent. Okay, it is what? Inconsistent. So these are the main things which you definitely have to know about the consistency. Okay, now let's see the next one. Next one, using inverse, how do you find the solution of system of matrix? Using matrix and inverse of matrix. So basically, let me take three matrices. Okay, so let me take three equations. First equation is a1x1 plus a1x plus b1y plus c1z is equal to d1. This is my first equation. Now let me talk about my second equation. A2x plus b2y plus c2z is equal to d2. This is my second equation. Now a3x plus b3y plus c3z is equal to d3. In this case, you are having three system of, like, this is a system of linear equations, right? Now, how can I solve it using matrix inverses? So, I can write these things in a single matrix equation. So, write in a single matrix equation. So how can I write it in single matrix equation? So basically I can write it as A capital X is equal to B. So basically what are my A? Your A matrix consists of these elements which I highlighted in yellow color. Same way your X matrix consists of the elements which I highlighted in pink color. And your B matrix consists of the elements which I highlighted in B, like, which is purple color. Okay. Now, how can I do it? So basically, So how can I do it? So basically, my capital A will be what? So my capital A will be A1, B1, C1. Basically, the coefficient of X, Y and Z in the first equation. Same way it is A2, B2, C2. The coefficient of the second equation. Okay. Same way A3, B3, C3. Like this you will be having. Now after this, what can be done? So here I'm having my X, right? So your X is basically what? Your X is small x, y and z. And what about your so now what about your B? B is nothing but D1, D2, D3. So this is my B. Okay. So are you clear? Are you clear? Yes? Are you clear? Yes. Now, let me tell you how do I find. Suppose if your A matrix, so here I am having my A matrix. If this matrix is a non-singular matrix, so how can I find whether it is non-singular or singular? Basically, what you should do, you have to take the determinant. So basically, is a non-singular matrix. So if your A is a non-singular matrix, which means what? Your determinant A is not equal to 0. So if your determinant A is not equal to 0, then your given system, this is your system, right? This system has a unique solution. So how do you find it? The given system has a unique solution. So how do you say this given system has a unique solution? Basically, capital X is equal to A inverse B. Like this only you will be having. So this system has a unique solution. Capital X is equal to A inverse B. That will be my answer. Are you clear? Like this only. So basically for finding the X value, Y value, Z value, what you should do, you have to take your A inverse first. After taking the A inverse first, then you have to multiply with the matrix B. Okay. Like this only you will be able to do it. So are you clear? So are you clear? Now this using matrix, if you find the system of linear equation, that is called matrix method or matrix rule. So this is basically called the matrix method or matrix rule. Using the system of linear equation and using the inverse of matrix, we are finding the solutions. In that case, you say that as a matrix or matrix rule or inverse of matrix. Okay, like this only you will be doing. So before going to the criterion, let's check few examples. Now I'm asking you to consider a system of linear equations such as 2x plus 6y is equal to 10. Then what am I saying? Then I'm asking you to see x plus 3y is equal to 5. So now let's check. First thing what you have to do is I have to separate my A term, X term and B term. So basically my A term is 2, 6, 1, 3. Okay, my B term is basically 10 and 5. My X term is basically, sorry, X term is not 6 and 3, X, small x and Y. Now what? Now I have to find my A inverse. So basically I have to find my XY value. So for that, what I should do? I have to check whether it is a singular matrix or a non-singular matrix, right? So let me check my A. So if I'm taking determinant of A, basically it is 2, 6, 1, 3. So now what should you do? Now I can do it as 6 minus 6, that will be equal to 0. So since it is a singular matrix, so what can you say? Therefore A is a singular matrix. Since it is a singular matrix, it has infinite number of solutions. So but the system has, how many solutions does the system have? It has infinite. Since it is a singular matrix, what can you deal it, like what can you say? It has infinite number of solutions. So this is my answer. So basically this equation you'll be getting infinite number of solution. Same way, now let's see. Now let me take another equation, such I'm taking it as x plus 3y is equal to 5, and now again x plus 3y is equal to 8. I am taking an equation like this. Now again how I have to split? I have to take my A. A is basically 1, 3, 1, 3. B is basically 5, 8. What is my x? X is basically xy. Like this only we'll be able to do. Now I am taking my determinant. My determinant A is equal to 1, 3, 1, 3. That is equal to 3 minus 3. That is equal to 0. So now when you look at the equation, this has, again this is a non-singular matrix. So it is a singular matrix. Sorry, it is a singular matrix, but when you look at the equation, so see it is exactly same. So what can you say? This has no solution. So but this system has no solution. So since this system has no solution, what can you say? Therefore it is a inconsistent. So the system is inconsistent. Okay, so what can you say about the system? It is inconsistent. Okay, now from this what can you infer? So if your matrices is non-singular, definitely it is a unique. Suppose if it is singular, either it can be an infinitely many solution or a no solution. So that is what you're going to infer. Let me conclude with that. So basically if A is non-singular, A is singular matrix, suppose if your A is singular matrix, then what? System of equations. So then what? The system of equations is given by Ax equal to B. It can either be, it may be consistent and having infinitely many solution. It may be consistent. So if you are having singular, it may be consistent. If it is consistent, that means it has infinitely many solution. So it is infinitely many solution. So since it has, so it means it has infinitely many solution, or it may be inconsistent. So what can you conclude? It may be consistent or it may be inconsistent. Okay, so if it is inconsistent, which means it has no solution. So this is the inference which you can conclude from this. Now let's see the criterion for, criterion means which is what are the criteria for consistency and inconsistency. Suppose you're having a linear equation, then you're splitting it and writing. You're splitting it and writing in terms of Ax equal to B. Suppose same way I'm just concluding, if your mod of x not equal to 0. So if mod of x means which is a non-singular matrix. Suppose if your A is non-singular matrix, which means system has unique solution. So it is given by x is equal to A inverse B. Suppose if your mod A is equal to 0, and how can you check whether it is no solution or that? And your adjacent A into B. So then what can you say? Your adjacent A into B is equal to 0. Then what can you say? Your system is consistent and has infinitely many solution. So then what can you say? It is consistent and has infinitely, so and it has infinitely many solution. Same way, if your determinant is equal to 0 and what can you say? Your adjacent A into B is not equal to 0. So if your adjacent A into B is not equal to 0 and your determinant is equal to 0, from that what can you say? Your system is inconsistent. Inconsistent means it has no solution. So therefore system is inconsistent. So what happens to my system? The system will be inconsistent. So are you clear with the concept? So I in the previous example you would have got confused because both has singular, but one solution has no solution, other solution has infinitely many solution. In this case you might have got confused. So if first check for the determinant, then after finding the determinant, what you should do after finding the determinant, if it is equal to 0, then check for Aj into B. Then you can come into a conclusion. Now let's go for the questions. Let's solve the questions. So basically I'm asking you to solve using matrix method. So solve what? 5x minus 7y is equal to 2. Then comes 7x minus 5y is equal to 3. In this solution, how can you solve it? So first, how do I do it? First, I have to split my a and b and x. So my a is basically what? 5 minus 7, 7 minus 5. Okay, now what about my b? My b is basically 2, 3. Okay, what is my x? X is basically small x, small y. This is my x. Now, what can you do? I am taking the determinant. So, determinant A. If I take the determinant A, basically it will be 5 minus 7, 7 minus 5. Like this it will be. Now, I am taking, only first rule is to take the determinant. Okay, now what can be done? Now, I am finding the determinant. Basically, it will be minus 25 plus 49. So, basically, what will it be? So, basically, it will be 24. So, your determinant is equal to 24. So, definitely, it is not equal to 0. So, what can you say? You can find the solution because it has a unique solution. So, now let me find it. For that, I should find A inverse B, right? So for this one, what should I find? I have to find my A inverse B. So now let me write my capital A11. So basically it is minus 5. So what is my A? My A is 5, 7, 7 minus 5. So A11 means basically I am removing this and this. So it is minus 5. Now what happens to the next? Next will be A12. So I'll be removing the first row and I'll be doing the second column. I'll be removing the second column. Sorry, first row and so, and you have to put minus 1 power. So, basically, how will it be is minus 1 power 1 plus 3 into 7. So, that will 1 plus 2 into 7, it will be minus 7. So, what is it? So, A21. So, basically, it will be the first row and this one. So, what will happen? Zn is equal to cos pi by 3 plus I sin pi by 3. Find the value of Z2. Yes, Meghala? Sorry, I'm not able to get you. What? Now, basically, it will be minus 1 plus 2 plus 1 into, it will be minus 7. That will be again equal to what? So, it will be minus of minus 7. So, it will be 7. So, this will be my, which question? Actually, which question? Actually, it is gone actually. So now what is A22? So basically second row and second column and it will be 5. So I have to write my adjacent A. So everyone makes the common mistake that you definitely have to take the transpose for finding the adjacent. So adjacent A is basically minus 5, minus 7, 7 and 5. Now, what is it? I'm taking the transpose of it. So, if I take the transpose of it, it will become minus 5, minus 7, 7 and 5. Like this only it will become. So, this is my adjacent A. So, what is my A inverse formula? My A inverse is basically 1 by mod A into adjacent A. That is my A inverse, right? So, it will be 1 by 24 into, what is my adjacent A? Minus 5, 7, minus 7, 5. Like this only it will be there. So, this is my A inverse. Now, when I further do it, I have to find my x. So, what is my formula for x? X is nothing but A inverse B. So, A inverse B is my x. So, basically 1 by 24 into, how can I do it? It is basically minus 5, 7, minus 7, 5. Okay. There is no n inside. If you have written Zn, but there should be cos some n inside, no? Cos pi by 3 plus I n sin pi by 3. Is it like that? Or power n cos pi by 3 plus I sin pi by 3 power n. Like this, maybe. Can you please check the question? So now I have to, what is my 2? Okay, so Megla, do message me in the separately. I'll work it out and I'll let you know. Okay, not in this session. Yeah, in separate session I'll work it out and tell you. Okay, like just message me. Yeah, in the helpline number. I hope you know the helpline number. So now what is my B? My B is nothing but, so B, what did I write it? My B is nothing but 2, 3. 2, 3 is my B. So 2 and 3 is my B. So it will be 1 by 24 into minus 10 plus 21 minus 14 plus 15. Like this only it will be there. Now what happens? I have to do 1 by 24 is equal to 11 and 1. Like this only it will be there. Now when I further do it, what happens? It is x and y, that is nothing but, when I multiply inside, is 11 by 24 and 1 by 24. Okay, so like this it will come. Now when I further do it, what can be done? So basically my x is 11 by 24 and my y is 1 by 24. This is my solution. Okay, so basically this is my solution and answer for this. Did you guys understand this? Did you guys understand it? This is 24. If yes, give me a quick fire. Did you guys understand it? And let me give you a quick homework or a question to be done. Just solve this sum and let me know if it is consistent or inconsistent. Just solve the sum and let me know if this sum is consistent or inconsistent. Suppose if it is inconsistent, tell me the reason. If it is consistent, tell me the reason. And if it is consistent, do tell me if it has unique solution or many solution. Yes. So that's all for today's session. Do comment below what you want in the next session so that I'll be able to bring up a video on that. So yes, do tell me a concept. So I'll explain the concept and I'll do one or two few sums. So yes. Bye. So yes, and thank you. Bye bye.